Welcome to The Explainer, where we break down big ideas. For all their incredible power, we're talking about models like ChatGPT writing poetry or Stable Diffusion creating these amazing masterpieces. They all have this one fundamental vulnerability, a single weak spot that can make or break them. So, what is it? Well, it all comes down to data, the amount of it, and even more importantly, the quality of it. That's the absolute foundation of modern AI. And if you get that part wrong, even the smartest, most powerful model is going to fall flat on its face. So, how big of a deal is this really? Let's dive right in and break down this whole data dilemma. Okay, so think of an AI model kind of like a student, right? To learn something new, it needs to see tons of examples. We're talking thousands, sometimes millions. But here's the problem. Real-world data is, well, it's messy. It can be super expensive and take forever to collect and label. And even when you get your hands on it, it's often lopsided, it's missing key perspectives. And that can absolutely cripple an AI's ability to perform in the real world.
And look, this isn't just some abstract theoretical issue. There's this benchmark called the Abstraction and Reasoning Corpus, or ARC for short, and it's designed to measure what you might call true intelligence. It's basically a set of new reasoning puzzles. For you and me, they're pretty simple. We can see a couple of examples, figure out the pattern, and boom, we've got it. But for an AI that's used to learning from these gigantic data sets, these puzzles are unbelievably tough.
So if our AI is basically starving for data, what do we do? How do we feed it? Are we just stuck waiting around for years to collect more and more information? Well,
Actually, no. The solution is this really clever collection of techniques called data augmentation. And here's the cool part. It's not about going out and finding more data. It's about creating brand new, high-quality synthetic data from the stuff you already have.
right, it's like a chef who can make a dozen different dishes from just a handful of ingredients. By making small changes to the data we've got, like, flipping an image or just tweaking a sentence a little bit, we can create tons of new, unique training examples. This teaches the model a much wider range of patterns, which makes it way more robust. It's less likely to get confused by something it hasn't seen before. Basically, we're making our data work a lot harder for us.
Okay, so how does this whole thing work in practice? Well, the techniques are actually super creative, and you use different tricks depending on what kind of data you're dealing with.
Let's start with images. For images, some of the transformations can be surprisingly simple but really effective. You can start with the basics, right? Like flipping an image, rotating it, maybe changing the brightness a bit. But that's just scratching the surface. The real magic happens when you get into the more advanced stuff.
Okay, so check this out. There's a technique called pixel erasing. You literally just delete a random chunk of the picture. So if you have a photo of a cat, the AI can't just cheat by only looking for the cat's face. It's forced to learn what the ears look like, the tail, the fur. It has to use the whole picture. And then there are even wilder methods like mix-up, where you literally blend two different images together to create this new hybrid training example. It sounds crazy, but it teaches the model how to deal with all the messy, ambiguous stuff it'll see in the real world.
Now, for text, things are a little different. You can't just flip words around like you're shuffling pixels, right? Language has rules, grammar, structure. You got to preserve the meaning. So augmenting text, well, it takes a much more delicate touch to make sure the new sentences actually make sense. But what's really interesting here is how simple some of these tricks can be. For instance, you can just swap out a word for a synonym, switch paint to draw. Or you could randomly stick a new word in there. The result? A perfectly valid, grammatically correct sentence that just slightly changes the flavor, giving the model yet another valuable data point to chew on.
And listen, this isn't just for pictures and words. These ideas apply to almost any kind of data you can think of. Got tabular data, like a spreadsheet? You can black out some of the cells. Working with graph data? You can randomly add or drop connections between nodes. And for time series data, you can stretch the timeline a bit or add a little bit of noise. It's a ridiculously versatile toolkit.
But look, creating more data isn't just about getting a better performance score. It's also about building fairer, more equitable AI. It's about engineering fairness right into the system. This is one of the most critical challenges in AI today, because biased data creates biased AI. Simple as that. If your dataset underrepresents certain groups of people or certain types of situations, the model's predictions are going to be unfair to them. It's like the model inherits and sometimes even amplifies the biases that are already out there in the world.
So how do you fight this? Well, you can tackle bias at 3 different stages in the whole machine learning process.
You can do it before training, during training, or even after. But one of the most effective ways is to get in there right at the start, before the model even starts learning. And that's where data augmentation comes back in. It's a key pre-processing technique for creating a more balanced and fair data set from the get-go.
A key goal here is to achieve something called statistical parity. Sounds complicated, but the idea is simple. A model's predictions shouldn't depend on sensitive information. For example, the chances of getting a loan approval should be the same whether you're a man or a woman, regardless of your race. The model's decisions should be independent of those factors.
So how do we generate this new data to balance things out? We can use some really advanced methods like generative adversarial networks, or GANs. And this is where it gets really cool. It's basically a cat and mouse game between two AIs. You've got the generator, think of it like a counterfeiter trying to make perfect fake money, and then you have the discriminator, the police officer trying to spot the fakes. They go back and forth getting better and better until the counterfeiter can create money that's indistinguishable from the real thing. This is perfect for creating brand new, super realistic data points to boost those underrepresented groups.
So, what's the big takeaway here? Data augmentation isn't just some clever little trick anymore. It's evolved into a fundamental engine that's driving AI progress forward.
And that brings us all the way back to that ARC challenge, the one designed to measure true intelligence. For the longest time, the best score was stuck at around 33%. But then, just recently, it jumped all the way to over 55%.
So what happened? Was it just a bigger, more powerful model? Nope. That massive leap was driven by new techniques where the AI essentially created its own data on the fly. Think about that. Instead of just learning from a static dataset, these top solutions are creatively generating and augmenting data to figure out problems they have literally never seen before.
So data augmentation is no longer just about making more data. It's about making AI smarter, it's about making it fairer, and maybe even more creative. It's pushing us right up to the next frontier. And it leaves us with a pretty mind-bending question, right? If we can teach machines to create their own data, what's to stop them from one day creating their own intelligence?